I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles, and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.
In this video, I'm going to talk about method and constructor overloading. You might want to import this project classes and objects extended, and in that open up the file overloading.java. Let's expand this. Sometimes you want to give two methods the same name, just as here. But in that case, they should vary in terms of signature. These two methods in here are having the same name, including the case, but they vary in terms of signature. When I say signature, it can vary based on the number of parameters that we send. In this case it's 2, and in this case it's 3. Or it can also vary in terms of the data type of these parameters. Now when we call this method, depending on number of parameters, the method will be called, or depending on the type of data as well. I've created an object of maths class, and then I'm calling object.addition, and with 2 parameters. Now any guess on which method will get invoked? It should be this, since we're taking 2 parameters. By the way, why do you want to have 2 methods with same name? That's because these 2 methods are essentially doing the same. They're trying to find the sum of all the parameters that you send. For the sake of readability, you might want to give the same name for both these methods. Okay, now going back, if we have another parameter here, which is 60, now this statement will call this method, and this statement will call this method. If you try to run the program, you would get 30 as the result of this instruction, and you would get 110 as the result of this instruction. Now let's try to add another method. Let me copy this code, this method, and change this to double. We will have a compilation error here because we're trying to find the sum of a double variable and an integer variable. Double takes more memory than integer, so obviously the result cannot be of type int. So the return value that we send must be double as well. Let's do Alt-Shift-F to give proper indentation. Now we can change, or let's add another statement. We can say 10.1 or 10.3, whatever. This instruction would result in calling this method. Although these 2 methods are having the same name, including the case, as well as same number of parameters, they are differing in the signature in terms of the data type. If I get rid of this method, do we see errors? We don't. Let's save the file. Why do we not see the errors? Because we're sending a couple of parameters, and this method would certainly suffice it. The parameter 10 is of type int while sending this parameter, but when receiving it, we have typecasted it into a double value. And it's not possible the other way. For example, if I'm sending a double value from here, and if I'm expecting an integer variable, then that's not possible. If you have gone through my video on typecasting, you would better understand this. So this works like charm. Let's undo, save the file. Now what if I change this type to double? We do get, okay, let's change the return type here. We do get an error. Where? Here. Because there is an ambiguity. We're calling addition and we're sending a couple of integers. Now compiler is not able to figure out which method to be invoked. Should it be this or this? This ambiguity causes the compilation error. Let's undo those changes. Let's run the program. Great, the result is as expected. Now let's take a look at constructor overloading. Same as methods, we might want to have constructors with the same name but with different signature. I don't have any constructor in this class. That means a default constructor is created. However, I can create my own constructor. Maths int x int y, and let's have a couple of variables in here, int x int y, and I said this dot x equals x, this dot y equals y. We will certainly have an error here because when we write a constructor on our own, there won't be any default constructor generated. While creating this object, we're not sending any parameters. So either we have to send a couple of parameters here, or we have to write a constructor without any parameters. Like so. And in this, I just don't want to do anything at all. So I could create another object with parameters 10 and 40. Need to give a different name, say object 2. This instruction will call the no parameter constructor, then this will call the constructor with couple of parameters which are of type int. Even in case of constructors, the signature matters, the type of variables and the number of variables that you're going to have as part of the constructor. Now sometimes you want to call this constructor from another constructor. For example, in this particular constructor, I don't want to set the value of x. I just want to take the value of y. So we get rid of it here as well. Save the file. Here we have a problem, right? Because we're not initializing this variable x. So how do we handle that? We call this empty constructor from here using the keyword called this. And as we've talked in our earlier videos, that this means the current object. And do take a note that the statement in here has to be the first statement. Let's say I do Control X and paste it over here. That's going to give me a compile time error. Let's undo. Now doing so, we're assigning our own value to y and we're leaving the x to have the default value. Hope that makes sense.
In this video, we're going to talk about recursion in Java. When a method calls itself, it's called recursion. Take a look at this example. Let's say you have a method called example, and inside that method we'll have some logic, and within this logic we're going to call the same method, example. So this will essentially call itself, and every time the controller enters inside this method and comes across with this instruction, it will call itself again recursively. This mechanism is called recursion.
One of the practical usages, or rather one of the most popular examples of recursion, is to find the factorial of a number. To find the factorial of number 5, we need to do 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. To find the factorial of 3, then that's 3 multiplied by 2 multiplied by 1. As simple as that. Now, how do we find the factorial of a number programmatically using recursion? Let's take a look. Let's say you have a method called factorial, and it's going to take one parameter which is of type int x. Essentially, we're sending the value to this method, for which we need the factorial. The factorial of 1 would be 1. The factorial of 5 would be product of all this, that would result in 120. So in our logic, if the parameter equals 1, that means we just simply need to return 1. However, if it is greater than 1, then we can find the factorial. How do we do that? Any guess? It's just one line of code that will do the magic. Can you try to figure out? If you observe this line, then we're finding the factorial of a number in this manner. To find the factorial of 5, we're going to say 5 multiplied by 5 minus 1. And whatever is the result, is in this case it's 4 multiplied by 4 minus 1. Again, whatever is the result of this, the result of this would be 3 multiplied by 3 minus 1. So ultimately we're trying to find 5 multiplied by 4 multiplied by 3, so on until we reach the value 1. So the result would be 120. We're going to have the same logic in here. So we're going to say else, if the value is not 1, then return x multiplied by factorial of x minus 1. Now try to think about this logic. You will definitely find the factorial of any given number. Let's say we wanted to find the factorial of 5, and that's what we sent as a parameter. Since 5 is not equals 1, we're not going to return the value 1. So we will enter inside this else block. In else block, we're returning something, x multiplied by factorial of x minus 1. What this statement essentially does is 5 multiplied by the factorial of 4. So 5 multiplied by the result of this method call. Whatever gets returned from this method call will be multiplied with 5. But in here, we're calling this method again, and this time the value, the parameter that we're sending is 4. So once again, 4 is not equivalent to 1, so we'll enter inside the else block, and hence the equation would be 4 multiplied by factorial of 4 minus 1, which will become 3. Again, 3 multiplied by factorial of 2. It keeps going until the value is 1. Once we hit the number 1, we're not calling this method anymore. So ultimately we're finding the product of 5 multiplied by 4 multiplied by 3, so on and so forth, and we get the result as 120. And there's one important thing to understand. Whenever you are using recursion, it is your responsibility as a programmer to put a terminating condition. Otherwise, the method will keep calling itself and will cause errors. The error that it causes is called Stack Overflow exception. The reason is every time we call a method in our stack memory, a new section will be dedicated for that method to store its local variables, etc. If you keep calling the method again and again, the stack is going to get full, and within no time you'll get an exception, and that exception is Stack Overflow exception. Let's take a look at example of these two. Let's go to our workbench. For this, you need to open the project classes and objects extended. In that, open the file factorial example. The logic in here is exactly what we have seen in our whiteboard. We have x equals 1, else we're using the recursion mechanism to find out the factorial of a given number. In this case, I gave 5. Let's see the result. Let's run the file. The factorial of 5 is 120. Let's give another value. Let's say I want to give 10. Let's save the file and again run the file. The factorial of 10 is this. We're good. Now let's take a look at this, the Stack Overflow exception. Now we haven't talked about exceptions yet. We will in our future chapters, but essentially you can think of it as an error. Let's take a look at this example. Let's run the file. So what are we trying to do here is we call this method in here. The controller enters inside this method, prints out this statement, and in our second line of this method we're calling the same method again. And there is no condition that will stop this. In case of factorial, we have this condition. If x equals 1, then we're going to terminate. Whereas in here, we don't have such condition. And moreover, do take a note that this message will never be printed because we just simply kept calling the same method again and again. Every time the controller comes in here, it's just going to go back to the beginning. So if you take a look at the output, we got, for every method call, there's a new section in the stack created, and after some time, when the stack got full, we got Stack Overflow error, and that's what it is messaging, and ultimately our build failed. So there's a risk associated with recursion. You need to use it very carefully. Always put a terminating condition. Let's go to whiteboard. Another practical example of using recursion is Fibonacci series. So what is Fibonacci series? It will start with 0, 1. We'll find the sum of these two, which will make it to 1. And then we find the sum of these last two digits. So that will make it 2. The sum of these two digits, we get 3. These two, 5, 8, 13, so on. This is called Fibonacci series. And the logic we're using in our program is somewhat like this. We have these variables declared and initialized. Now we're going to try to print first two values, 0 and 1, using system.out.println. And in our method Fibonacci series number, we're going to send a parameter. Let's say we send the value 1000. We want Fibonacci series until 1000. So the way we are dealing with it is using these three variables. We're going to find the sum of a and b and store whatever is the result in this fibnum, and then So that means essentially, let's say the value of initially the value of a and b or 0 and 1, we find the sum of a and b, that will make it to 1. So the fib num value would be now 1. I'm going to store the value of b into a, and we're going to store the value of this result into b. And we're going to print this number, fib num, using system.out.println. Now the values of a and b are updated to 1 and 1. And again, we'll try to find the sum of a and b, so that will make it to 2. We're going to assign the value of b in a, so that will make the value of a to 1. And then the value of b will become 2. So we got these two values. Again, we'll find the sum of these two values, store the value of 3 in fib num variable, and a will now hold the value of 2 and b will hold the value of 3, so on and so forth, and we'll have a terminating condition. Whatever is the value that we send to that method is the maximum value, and we don't want to generate any Fibonacci numbers beyond that number. Now let's take a look at that example in our code. Here it is. We have these three variables in here. We have the max limit of 1000. We're just simply printing the values. The first initial values would always be 0, 1, so we're just right away printing them. And we're calling this method Fibonacci series. This has the logic which I'm talking about, and this is the line that does all the magic. It's going to call itself recursively until this condition fails. Let's try to run this program. There you go. Let's give the value of 10,000. Let's save the file, run it again. There you go. Hope you've enjoyed. In this video, we're going to talk about nested classes. Take a look at this. Let's say we have class A and class B, and all the members of class B are public, and the only reason why class B's members are public is because class A is using them. Class A needs access to all the members of class B. Now let's say class A is not there, then we can gladly mark all the members of class B as private. Now just because of one class, we are making all the members of class B as public. This is clearly a problem. This will impact one of the major features of object-oriented programming language, is encapsulation. We need to try our best to make as many members as possible to private. But Java gives us a solution to this problem. We can make a class sit inside another class. So a class inside another class. In this case, we just simply put this class A inside class B, so that A being a member of class B, the class A will have access to its private variables, to class B's private variables and private methods. So the problem is solved. Now we can gladly make all the members of B as private. This will improve the encapsulation, and that's clearly a great advantage. Coming to the syntax, it's pretty simple. We have class B. It will have its all member fields and member methods. And within this curly braces, will have another class defined, class A, and then it will have its own member fields and member methods. As simple as that. So we're basically nesting a class inside another class. It's called nested class. In that we have static nested class and non-static nested class. This is also called as inner class. Now let's take a look at both these examples in our workbench. See you there. Let's talk about static nested class first. So in here we have the outer class, and then inside it we have another class defined. Within this class we have a method that just simply prints a message. But do take a note of this keyword, static. When we say static, this class in here will not have direct access to the instance variables, because when we have a static member, just as static method, a static class is associated with the class. It's not associated with an instance. In order to access this method met from outside this class, this is how you would do. This is the name of the outer class and then the inner class with the dot operator. You'll give it some name, and then new, you're going to repeat the same thing so that we got an object of the nested class. You can call the method like so. Now this statement makes complete sense, because let's say we have a method which is of static. How do we access that method? We use the class name. That's exactly what we're doing here. This class in here is more or less like a member method. So in order to access this, we can just use the class name, since this is static. And that's what we did. We use the class name to access its member. In this case, it's just another class. And then we do need to create an object of the inner class. That's because the member function that we're trying to access is not static. So we need to have an instance or an object to be able to access this method. So in here we have a new keyword used that will create a new object of the inner class, and using that inner class object we're able to call this method. And let's say if this is static for the time being, let's save the file, and then I bet we would be able to access it directly like so. There it is. Let's undo those changes. If you run this file, then you would just see this message printed. Let's give it a try. There you go. Now let's take a look at non-static nested class or inner class. We have the similar syntax for this. We have an outer class, and inside that we have an inner class. But there's one key difference. This class in here is not static. And the way we access the member methods of the inner class is like this. First of all, we need to create an object of the outer class, and then we will create the object of the inner class using the reference of the outer class. We'll take a look at how it's done, and then we'll be able to access its member methods. So this is how it is. We have an object of outer class, and then you need to have the following syntax to be able to get the control of the inner class and access its member functions. You have the name of the outer class, and then name of the inner class with the dot operator. You give any name in here, and then the object of outer class dot new. This is very important. This is what does the magic. It will create an instance of the inner class, and then here it is. We're able to call that method. If you run this program, you would see this message. Let's quickly do that. There it is. Let's talk about some of the key differences between these two types of nested classes, static and non-static nested classes. Unlike a static nested class, the inner class will have access to the instance variables. For obvious reasons, because this class is not static, hence it is associated with an instance, not with a class. If we have a variable defined in here, then we can gladly access those member fields of the outer class from the inner class. But that's not the case with the inner class in here, because it's static and it does not have access to instance variables. Now that being said, Java does not encourage us to declare any static members in here, be it static fields or static methods inside this inner class. There is one good reason to do so. That's because it will violate the definition of static. When we say a member is static, that will signify that we shouldn't be needing to create an instance to be able to access it. We should be able to access it with just the class name. But if we have a static member in here, for example, there's no way we can access it without ever creating an instance of its outer class. Because only when we create an instance of the outer class will we ever get control of its inner class. So it just doesn't make a lot of sense, and hence the designers of Java decided not to support static members inside a non-static inner class. But that being said, we can still create constants. For example, static final x equals 10, or static final the pi is 3.14, etc. That is allowed inside this class. You can give it a try if you want. And one of the beauty of these inner classes is that you can make use of the access specifiers just as you do on member methods. You can have public, private, protected, and default access specifiers on a method. In the same way, you can have all those access specifiers for inner class as well. For example, I can make this private. Doing so, obviously we will get an error here because we cannot instantiate the inner class anymore. We can instantiate it, but only within the class in which it is residing. Only the outer class will have the permission to create instance of the inner class. Let's undo that. Now you might be wondering, when we don't have access to, okay, let's go here. When we don't have access to the instance variables, what is the real reason why we would ever want to use a static inner class? One of the key examples which I can explain right now is this in here will have access to private constructor. Let's try to create a constructor. With some message from private constructor. Alright, inside this method we can create an object of this class. Let's comment this line. And now from here, if you run this program, we'll call this method and we have access, we have created an object of the outer class. But take a note that you cannot create an object of a class whose constructor is private. We cannot create the object directly from this class, but we're able to do so in here. That's because this is a static class and we're able to call this method without ever creating an instance of its outer class. In here we have never created the instance of the outer class. But whereas coming to inner class, the non-static inner class, we do have to create the instance of the outer class, and we cannot if we have a private method in here. Now let's try to run this program. Run file, message from private constructor. Great. See you in my next video. In this video, we're going to talk about shadowing. Take a look at this example. We have a class, and inside that we have another class which is an inner class. We also have the main method from where the execution begins, and all we're doing inside this method is we're calling the method inside the inner class and we're sending a parameter. Now if you take a note, the name of all these variables are same. One is sent as a parameter, which will be the local variable of this method. The other is the instance variable of the inner class, and the other is the instance variable of the outer class. Now when I try to run this program, what would be the output of this line? Any guess? Java will shadow both these variables and it will give priority to the local variables, which is in this case it's 5. If you want to access the instance variable of the inner class, then you have to use the keyword this with the dot operator. This will refer to the current object, which in this case is the inner class object. So this statement will display 1. If you wanted to access the instance variable of the outer class, then you're going to do it this way. The name of the outer class and use the keyword this dot the variable name. Let's try to run the program. There you go. The result is as expected. In our next video, we're going to take a look at local classes. Stay tuned. In this video, we're going to talk about local classes. Unlike an inner class which acts like a member of a class, a local class is local to a block. And when I say block, it could be inside a method, it could be inside a for loop, or even it can be inside an if condition, etc. Now take a look at this. We have the main method from where the execution begins. We have an object of the outer class using which we are calling a method inside it. Inside this method, we have another class defined which is called a local class. And we've also created an object of that local class to be able to access this method inside that local class. Now this local class acts more or less like an inner class. It will have access to all the private members of the outer class. And just as inner classes, a local class does not encourage us to put static members. No static variables or static methods, except the constants, the final static variables. Now that being said, there are certain differences between the both inner class and the local class. For example, we cannot instantiate the local class outside the scope wherever it is defined. For example, this local class is within the scope of this method, so we cannot create an object of this class outside the scope. And this local class cannot have the access specifiers like public, private, protected, whatsoever. And for obvious reasons, that's because inner class is like a member of a class, and every member of a class can utilize the access restriction. Now this is inside a method. this is not a member of a class, and hence access specifiers or access restrictions is not applicable for local class. Also, whenever a local class is using a variable that is local to this method, be it a parameter or a variable which is declared and initialized inside this method, it should be a final variable. Otherwise, we get a compilation error. There is a very good reason to do so. This class in here does not have visibility of the local members or local variables of the enclosed scope, or in this case, the local variables of this method. But Java does a little trick to this. When we compile this program, Java will actually create a copy of these local variables and make them part of this class. And at the same time, Java will also create a constructor to give the initial values, which would be the same values whatever we have here. So Java is essentially, during compile time, is just making a copy of all these local variables and pasting them here with a constructor to initialize them. So during runtime, if the variable is not final, then there's a scope of changing, and that will definitely cause confusion. Let me explain you what I mean. Let's say I have assigned the value of x to factorial of x. Of course, we don't have this method, that's why we're getting compilation error. But just for the sake of explanation, let's assume we're finding the factorial of the value x and then assigning it back to the same variable. Now, if you observe, Java is actually creating a copy of variable x during compile time, but this computation happens during runtime. Java cannot predict ahead of time during the compile time the result of x. So the only way we can restrict to not make changes to these local variables is when we make it to final. So that's the very reason why we have a compilation error. Okay, let me just show you updating this value x to 30. Error. Hope that makes sense. Now you may ask me, this variable in here is not final, but still we didn't get a compilation error. This is not final, but this is effectively final. Since Java 8, they removed the restriction of making a variable as final, but it should be at least effectively final. What that means is I didn't make any changes to this variable, so that means effectively it's a final variable, and Java will allow me to do so, allow me to access. Now let's say I update the value to 40, let's say. Now this will definitely show an error saying local variables referenced from the inner class must be final or effectively final. Makes perfect sense. Let's get rid of this. If you run the program, you would definitely see the value 10. Let's do it. There you go. See you in my next video. In this video, we're going to talk about string data type. String in Java is nothing but collection of characters, just as a word in English language, which is collection of letters. This is how we represent a string in Java. Now, by taking a look at this statement, you may think that string is a primitive data type, but actually it isn't. String is a non-primitive data type or user-defined data type. So essentially, string is a class, and we're in fact creating an object of this class to be able to create this string. Well, we're not explicitly creating an object using the new keyword, but Java does that for us. So this statement in here can be represented in this manner as well. We have a character array which has all these characters, A, P, P, L, E, and we're sending that character array as an argument to the constructor of string class. These two statements in here,
does exactly what this single statement does. For the convenience of the programmer and to save time and effort, Java designers gave a shorter way of representing these two statements. So let me comment them out. Save the file. If I try to run this program, then we would see Apple as the output. Let's do that. Let's comment this line and try to run the program by uncommenting these two lines. We would see the same output. Great. So why Java designers decided to have string as a non-primitive data type? That's because it gives us lots of flexibility. There are lots of methods in this class string that we can utilize for our own convenience. For example, let me just uncomment all these lines of code. Save the file. Now by calling a method inside that string class called length, we can get the length of that string, whatever the string is. Similarly, we can convert that string to uppercase by calling this method called toUpperCase. We can replace a character. We can find the position of a certain character. We can also extract the substring of a string. For example, in the string apple, we might want to get a substring like PLE or something like that. Now let's see how this program works. Let's run the program. Here it is. We're able to utilize that string class and perform certain operations on the string. There are many such methods in string class. For more information on them, you can refer to this link. Actually, you don't have to go inside this link. If you just use the dot operator, your IDE will suggest what are the methods available that are of public. And we also have explanation of each and every method. So you can just go through it. It's pretty much self-explanatory. Let's undo and save the file. In our next video, we're going to talk about string as immutable. Open the class called string immutable under the package string package. Let's expand it. Can you make a guess on the output of this program? We have a string here. We're trying to convert that string to uppercase and we are printing it. Would the output be uppercase apple or would it still be apple? Alright, string is said to be immutable. That means once the string is there in the memory, nobody can ever change it. And when I say string is immutable, I'm only talking about the literal, the right hand side of this equal sign. We can always change to which object this reference type points to. If I run this program, you will not see the uppercase apple. You would still see the apple, lowercase apple. Let's run the program. Now before you start yelling what the hell is going on, I'll take you to the whiteboard and explain you in more detailed fashion. Let's go there. So again, we have our stack memory and heap memory. Now this statement in here, as we've looked at in our previous example, will essentially create a new string object using the keyword new. So the reference type would reside in the stack and will point to an object inside the heap memory, which in this case it would be string apple. This is not the case in case of string. What actually would happen is
We have a special memory inside this heap, which is called string pool. And this string object would be created in here. And this reference type would point to this object. So why do we have a string pool? You will understand that in a minute. You will also understand why string is immutable. Let's say I have another statement that says string str2 equals apple, the exact same string what we have here. So this being reference type, we'll have it inside the stack str2. This statement will not create a new object inside the string pool. Instead, it would just point to the exact same object, because they're essentially holding the same exact string, apple. Now, can you guess why Java designers made string as immutable? That's because, let's say we have a statement that says str dot to uppercase. If the string is mutable, then this statement will make changes to the actual object, and this will impact str2 because it is pointing to the exact same object. Likewise, there could be many number of string references which are pointing to the same object across all the programs. So we cannot let the programmer make changes to that string at any given point of time. So this answers why string is made immutable. But why do we have string pool in here? By now you should have understood it. We have string pool primarily to save the memory. So these two string reference types are pointing to the same object. We didn't create two different objects for these two instructions. That saves the memory of one object. If we have 100 strings created which are holding the same name, same string, apple, then all of them would actually point to the single object in the string pool, and it won't create multiple objects. So there's a great memory advantage. But just in case, if you decide to not bother about memory, and if you decide to create string object in heap memory, there is a way to do that as well. So this is how you do that. String s1 equals new string, and then you will pass the string as an argument to the constructor of this class, which would be, say, banana. This instruction will create an object inside the heap memory, as well as a copy would be created inside the string pool. Now let's say we have another statement, the exact same statement but with a different name. New string, say banana. Ignore the typo. Now this will create another object inside the heap memory. So although the strings are same in this case, two different objects would be created in the heap memory. Now let's say we have one more statement, say string s3 banana. Would this create a new object in the string pool? It won't, because by doing this statement we've created an object in heap memory as well as in the string pool. So this statement, the s3, will point to banana in the string pool. Hope that makes perfect sense. Let's go back to our program. But before that, let me just show you one of the security threats had it been the case that the string is mutable. Let's say you have two computers. Computer 1 is authentic
and computer 2 is insecure. It has some malicious software in it, and you don't want to access that machine from your program. In your program, you have a method that says connect, and you're going to send the IP address or the system name as a parameter. Your program will check to see if the connection is secure. If it is not secure, then you're going to exit. If it is secure, then you're going to go ahead and connect and do some operations. Now let's say you sent argument as computer 1. This check will pass because it's a good computer. But before you reach the statement connect, some other program would modify this string to computer 2. So you're actually connecting to a computer which has malicious content in it. This is a serious security threat. Thankfully, string being immutable, nobody can ever change this, computer 1. Hope that clarifies. Let me just uncomment this code in here. In our previous example, we have already looked at the use of double equal sign for primitive data types. But this operator will also help us in checking to see if these two reference types are pointing to the same object or not. Can you make a guess on the output of these three instructions? Okay, this line will create a new object in the string pool and has the reference A. We have another reference B, and will actually point to the exact same object created in the string pool. So hence the output of this line would be true. These two reference types are actually pointing to the exact same object in the string pool. Coming to this instruction will create a new object inside the heap memory, and this instruction will also create a new object in the string pool. This will point to the object residing in the string pool. But these two are two different objects. One is in the heap memory, one is in the string pool. So this statement would return false. Now how about this? These two are two different objects in the heap memory, and hence this would be false. Let's try to run the program. There you go. There could be times where you want string to be mutable. That means changeable. In that case, you want to use string buffer class. Let's expand it. I have an object of string buffer, and I'm sending a string as an argument to its constructor. I'm also calling a method inside it, append. This will append this string, basically whatever I send as an argument to that method. And this works. This statement in here will club both these strings and print as a single string. The key thing to understand is we're able to modify the string itself. So what is one good reason why you would want to use string buffer? Is it has a performance advantage. For example, take a look at this line. We have two strings, and using the plus operator we're performing concatenation. Although this line looks simpler than these three lines, in terms of performance this will perform better. Also, there are some methods that are part of string buffer that you can utilize. For example, we can insert some text at a particular point in that string. In this case, we're trying to insert this text at index 10. and we're printing this statement. We can also reverse the string. This will reverse the string. Let's run this program. These two strings are clubbed. I'm able to append this string, and in here we inserted this text at index 10, so that's some text inserted, and we reversed everything, the entire string. It's better to use mix of both. So once I do all sorts of manipulations that I need to do with the string, it's better that we convert that string buffer to a string class using the method toString. So once we convert this to string, then again the string will become immutable. So you can utilize the advantages of both string and string buffer. We'll talk more on the string buffer, string class, and string builder at later point of time once we cover the concept of multi-threading. For now, this should suffice. See you in my next video.
In this video, we'll talk about Java Virtual Machine Architecture. JVM is a pretty complex architecture. That being said, we don't need to know each and every component in it. I'm just going to walk you through some of the major components that will add some value to your learning. Moreover, there are multiple vendors for JVM, and each vendor will have their own architecture for their JVM. So no matter what architecture I introduce to you, it won't be a complete architecture. So let's just focus on some of the major components that are commonly found in any Java virtual machine, and I bet you don't need to know anything more than that. First of all, you have your source file or the Java file. We compile it and then we get a .class file or the bytecode. Now this .class file will be fed into the Java virtual machine, and this is where all the magic happens. Now let's go deep into it. At a very high level, there are three major components in JVM. Number one is class loader subsystem, which is majorly responsible for loading all the required class files into the system. Now, I'm not going to write the complete words, that would mess up everything. So I'm just going to represent with few uppercase letters, like so. You may want to pull a pen and paper and take down the notes if you're interested. Now, the second major component is execution engine, and we'll have things like just-in-time compiler, interpreter, etc. And the third major component is runtime data access, and is majorly responsible for fulfilling all the memory needs for JVM to run your code. Now let's go deep into it. The first component that comes into this picture is class loader subsystem. The class loader subsystem is majorly responsible for loading the class files, and in order to perform loading, there are a few other subcomponents that come into picture. Number one is loader. The job of loader, as the name suggests, is to load all the necessary files into the Java virtual machine to run the program. The loader is actually a combination of three different things. One is Bootstrap class loader. Bootstrap class loader is a program that will load all the class files that are essential to run your program. Essentially, it's rt.jar file from your JDK directory. RT stands for runtime, and without loading rt.jar into the system, JVM is virtually useless, because the rt.jar constitute all the key files that JVM uses to run your program. Also, it's worth noting that this Bootstrap class loader program is actually written using a native language like C, C++. The second subcomponent of loader is called extension class loader, and is responsible for loading all the .jar files that are in extension directory. This is essentially the folder named ext in your JDK directory, and typically if you want to use any external class files or .jar files, you would keep them in this extension directory.
We've already talked about a scenario where you're using an external .class file. By the way, if you don't know what's a .jar file, for now you can think of it as combination of one or more .class files. So whatever you keep in the extension directory will automatically be taken into the JVM. Now the third subcomponent of loader is called application class loader, which is responsible for loading all the class files from the class path. In the beginning of this course, we've talked about configuring the class path. Whatever resides in that class path will be loaded into JVM by application class loader. Now the second component of class loader subsystem is linker. The job of linker is to verify that the generated bytecode is in proper shape. Basically, it would sort of perform a compliance test and would see if the bytecode is compliant or compatible with the Java virtual machine. If there is any problem with the bytecode, we would see a runtime error. You would almost never come across with this error though. The linker will also allocate memory for all the variables present inside the class file, which also includes static variables. And not just allocating the memory, but also updating the variables with their default values. For example, for integer, it's the value 0. And finally, we have initialization phase. This is where all the variables will be assigned with their actual values. And this is also the phase where all the code in the static blocks will be executed. Now, I guess I haven't yet talked about the static block. We'll talk about it pretty soon. The second major component of JVM is runtime data access. In this, we have something called method area. I said that the loader will load the class files, but where does it load? It's in this method area where all the data will be stored in class structures. And the data gets stored in certain format so that the execution engine will be able to execute the code comfortably. Also, the data in the method area would be identified with a unique address. The second memory section we have is heap area. We've already talked about heap area many times and we know what it is, so I'm not going to go through it once again. Now guess what? We have stack area and we know what it is. We've talked about it in our previous examples. And then we have something called PC registers or program control registers are there to hold the address of the current executing instruction in the program. Once the current instruction is executed, the PC register would be updated with the address of next instruction. That way it keeps on getting updated till we reach end of the program. Let's talk about execution engine. As I've already mentioned, this would have components that will help execute the program. So this will have the interpreter, and we know what it is. It has just-in-time compiler. We've talked about it in the beginning of this course. And finally, we have garbage collector, which is a process that happens periodically where all the unreferenced objects will be wiped off from the memory to save the memory for other objects. And we have something called native method library. These are all libraries that are essential for you to run a native program. For example, let's say that you wanted to run a C program from your Java program. So you would make use of these native libraries to be able to do so. Because JVM is meant to run Java programs, not native languages like C and C++. And we have JNI, stands for Java Native Interface. It is basically an interface which the execution engine uses to kind of access the native libraries to be able to run the native program. There is also a separate memory section dedicated for running native programs, and that is called native method stack. All these components sort of work together to accomplish the task of running your Java program. Isn't that amazing? Also, I just want to quickly talk about the role of JVM in multi-threading. Now, we probably don't know what is multi-threading. We have a chapter dedicated for that. It's a pretty big chapter, by the way. But just for the sake of this video, for the completeness of this video, I'm just going to give a quick overview on what is multi-threading. Let's say that you have a program and say that you have few instructions that will help you download a file. And say that the download will take around 10 minutes of time. And then in another section in the same program, you're doing some kind of a mathematical operation. Now if you observe, these two operations are completely independent of each other. The mathematical operations that you perform has nothing to do with the file download. Now the problem here is, if you run this program, this section will have to wait until the file gets downloaded. Why should we let that happen? This is where the multi-threading will come into picture. If we can separate these two tasks into two different threads, say download operation in thread T1 and this mathematical operation in thread T2, now these two threads can actually run simultaneously. That way we're saving a lot of time. If this sounds confusing, then you'll have to wait until we get to multi-threading chapter. But the reason why I'm explaining you this is, let's go back. These two memory sections, PC registers and native method stack, will be allocated for each and every thread, while method area, heap area, and stack area will be shared across all the threads. So say that you have 10 threads, then for each and every thread, you got an individual PC register and native method stack. But all those 10 threads will share all these three memory sections. Again, if this sounds confusing, you'll have to hold on until we talk about multi-threading. Alright, that's it on this video. See you soon.
So far we have used NetBeans IDE to run our Java programs, but now it's time to move on to Eclipse IDE. Now I remember I told you that we're going to go through all these features in here, but I felt it's better that I talk about all these features in the Eclipse IDE itself, not to create any confusion. Eclipse is the most popular integrated development environment used in the software industry to help build the Java projects. Eclipse is also an open source supported by thousands of contributors, and it definitely makes a perfect choice for developing Java applications as well as the Android applications. So why should we wait? Let's go ahead and download and install it. Go to eclipse.org and then click on download. We have multiple versions of Eclipse. By the time of this recording, Eclipse Neon is the latest one. So let's download it. My PC is 64-bit and that's why I'm downloading 64-bit version of Eclipse. Let's click download. Our download started. Okay, I have that downloaded. Let's install it. Run as administrator. By the way, I have moved my operating system to Windows 10. The reason why I mentioned Windows 7 earlier is because by the time of this recording, Windows 7 is the most popular operating system. And hence, I have told you how to configure your Java environment on Windows 7 operating system. It's exact same steps which you need to follow even in Windows 10. Let's move on. Click yes. We have Eclipse IDE for Java developers and an IDE for Java Enterprise Edition developers. We also have Eclipse for C and C++, so on and so forth. But what we want is either of this. Since we're in our future videos, we're going to get into Java 2 Enterprise Edition. Let's install that. Click on install. Accept the license, of course. Accept the license again. It's going to take quite a while. Click launch. You can give any directory that you wish. I'm going to give new Eclipse work directory under E drive. So this would be the place where all your projects would be residing. Click OK. If you're interested, you can go through these tutorials, samples, etc. But I would just like to skip. So here is the Eclipse, the most popular IDE for developing Java apps. Let's try to create a project. Click New. And what we're looking for is Java project. We have many different types of projects that we can create, but most of these are at the moment or not of any use. Select Java project, click Next. Give the project a name, First Project. If you want, you can play around with these options, and let's finish. This will create a new project. Click Remember My Decision and click Yes. Here we have our project. Now right click on it, click on New, Class, give it a name, First Java Program. Now the beauty of Eclipse IDE is that you can play around with these options. If you want main method to be present, then you just have to check this checkbox. Similarly, if you want to have constructors from superclass, obviously you don't know the term superclass as of now. You will get to know about it when we talk about inheritance, etc. But just take a look at this and have a glimpse of what it is doing. Let's click Finish. So here we have our first program. Now here is a little surprise to you. Eclipse IDE is actually a lot easier than NetBeans IDE. As you can see, we have a menu item that is similar to a Word document. If you click any one of them, let's say source, and by just looking at these words, you would be able to figure out what it does. For example, you can generate getters and setters, etc. Obviously, we're going to be using majority of these functionalities pretty soon. Stay tuned. Okay, let's talk about our first Java program. Let me just insert a statement in here, which is a simple system.out.println. Let's expand this by double clicking it. So far, we haven't yet talked about our first Java program. If you take a look at other tutorials, they'll start right off with their first Java program and try to explain you everything. But now, I bet, by just looking at this program, you would be able to figure out what's happening. For example, we know what public is doing here, and we know what static is doing here, and we also know why main method has to be a static method. We know this is a return type. We're not returning anything from the main method, hence it's void. We also know what this statement does, as we talked about it earlier. The only thing that's strange to you is this. You can easily guess that we're sending a string array as an argument to this method main. But how do we ever send an argument to a main method? Let me introduce to you command line arguments. Before we take a look at how we send arguments to the main method, the string array, let's have a couple of instructions that will loop through all the elements of the string array and just print them. Now let's see how we can send arguments. Click on Run, Run Configuration, choose the program, click on arguments, and send a couple of arguments here, like so, and click on apply. I had already done that. Click run. See, we have those arguments printed. This all looks complex, but essentially what we're doing is, remember our first Java program? Before even installing the NetBeans IDE, we had run our programs through command line. And when we do so, we use the command that looks something like this. We did Java and then program name. This is how we run our Java programs, through command line. But in addition to this, we just send some arguments, some random text with the space as a separator. Whatever you enter here as an argument separated by a white space would be sent as an argument to the main method, and that's nothing but command line argument. The Eclipse way of doing this is by going to run configuration and then arguments, provide your arguments. Now I know this all process looks a little complex. You're probably annoyed at the moment looking at all these tabs, etc. Trust me, in just a few chapters you feel absolutely comfortable with Eclipse IDE. It's pretty easy to use and is meant to make your life easy. Let's close. See you in my next video.
I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles, and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.